So here we are at 10.7, and we're going to look at first the root test. Well, this is going to be a very short video because the root test is a very specific test that can only be done in certain situations. And as you can imagine, since the root test uses a square root, it can only be done when an entire series is being raised to the kth or nth power. So, all right, let's get started. Let's suppose we have a series a to the n, and we're going to assign a limit to that series, and we're going to call that limit rho. We're going to let rho equal the limit as n goes to infinity of the nth root of a sub n. Now, you might be asking, well, why are we taking the nth root? The only reason we're taking the nth root is because your series, for example, is going to be crazy things. And here, I'll show you the one we'll take a look at. Might be something like, oh, I don't know, 4n squared plus n over 9n squared plus 1, all to the nth power as n goes to infinity. So it's the fact that you're the only time you're actually going to use the root test is when you have, a more complicated ratio or a sub n inside raised to that nth power. So now you can see, well, what if I take the limit of the nth power, meaning I get rid of the exponent, is what we're looking at. So as I said, they're only used in very, very specific situations. So now, let's suppose, well, we're going to take the limit by getting rid of the exponential part. We're just going to basically take the limit what's inside. If rho, that limit you find, is between 0, greater than or equal to 0, but less than 1, well, you converge. Okay? If that limit is actually larger than 1, you're going to diverge. Your entire series diverges. And, well, there's always that time when you don't know if it's converging or diverging. And if rho equals 1, it's inconclusive. And if it's inconclusive, well, you have, 8 other tests that you can try. So let's just take a look at one quick example for when you would go to the root test. So we'll do the example I have up there, all right, which I'll rewrite as the summation 4n squared plus n over 9n squared plus 1 to the nth power, n equaling 1 to infinity. So I have this series. Again, this is what tells you to, hey, try the root test, okay? Because we're going to get rid of the exponent with the root test. All right, so the root test says I want the limit of this entire, the limit of the nth power, nth root of that entire series. See, I want to do this. Well, what happens when you take, I'll do it in green for a minute, the square root of the nth root of that. The nth root cancels the nth power, right? So I'll write it out for this one. Let's do it. Limit, this is what my rho is going to equal this limit. N goes to infinity of the nth root of to the n power. Now you don't have to write that because, again, nth root cancels nth power. You can simply, you don't have to show me that step. You can simply write it as the limit of what's inside the parentheses. Oh, that's a pretty easy limit to take, correct? I mean, you can L'Hopital everything. You get 8n plus 1 over 18. And then you can L'Hopital it again to get rid of the n, or you can just use the fact that the idea that these are the same, so it's just 4/9. Whatever you need to do to feel comfortable with your row. So what does that mean? That means my row equals 4/9. And this is the part you have to remember. Because again, I gave you that paper. I uploaded it. You have that paper. It's a summary of all our tests. You have to understand, I took this limit. What does 4/9 mean? Well, 4/9 is between 0 and 1, so my series converges. All right. So converges. So you would say by the root test, our series A sub n converges. And that's it. So again, all you're doing is taking the limit of what's of what's inside here, right? And if that limit is between 0 and 1, it converges. Greater than 1, it diverges. And if it equals 1, it's inconclusive. That means there's another test that could be done on that particular series. Okay, so that's it. That is our, told you this one was going to be a short one. That is our root test. Again, only can be used in a very, very, very specific situation. But if you use it, it's a quick limit and usually a pretty quick test to conduct.